Hi there. Welcome to another burst session for the Richmond School District. My name is Janice Nowakowski, and I'm a district teacher consultant for K-12 mathematics and numeracy. This is actually the final session of a series that we've been doing on computational fluency for K-5 mathematics. And this session will focus on the assessment of computational fluency. So again, just as a reminder, computational fluency is the calculation of numbers using the operations of addition, subtraction, multiplication, and division. And it is defined as having efficient, flexible, and accurate methods for computing. In our BC curriculum, it lives in a big idea. It's the second big idea in our K-9 curriculum. And the meta big idea is that computational fluency develops from a strong sense of number. So each grade level has a more expanded big idea in terms of computational fluency at that grade level. And when you click on the big idea, you can also see inquiry questions to support students' investigations into computational fluency. And then there are also complementary learning standards for both content and competencies that develop children's computational fluency at specific grade levels. We have a continuum of computational fluency in our curriculum that begins in grade 1 for addition and subtraction, where the concepts and processes of addition and subtraction are introduced. And then as the grades develop, there's more fluency expected as students learn different strategies, mental math strategies, and begin the recall of their addition and subtraction facts. For multiplication and division, that begins at grade 3. And again, would extend into grade 7. Part of that extension across the grades is applying those strategies with smaller numbers to working with larger numbers. So what is the process of assessment in general when we think about our BC curriculum? We collect and analyze evidence of learning that's connected to a learning goal. So we've designed our instruction and our learning experiences based on a learning goal that we've developed that is rooted in the BC curriculum learning standards. So again, content and competencies. We determine what students can do and what they know and understand, and we provide descriptive feedback to them and what are their next steps. When we do formal learning updates, we evaluate where they are along the proficiency scale and communicate that to both the students and their families. When we're collecting evidence of student learning in British Columbia, we draw upon this assessment triangle that was popularized in British Columbia by Karen Cameron and Kathleen Gregory, who are BC educators who wrote the book Rethinking Letter Grades. And they drew upon the research of Lincoln and Guba from 1985 and Dr. James Popham, who looked at collecting multiple sources of data when we're assessing learning in order to get an accurate a picture of what the student is able to do and what they know. So looking at products, things that students might write or create or build, observations of students doing things or interacting with materials, and then conversations with students. And that could be student interviews. It could be during math workshop when we're working with small groups, or it could be during a math talk, like a number talk, where we're engaged in mathematical discourse and we're noting how students are using language to communicate their mathematical thinking. When we look specifically at assessment of computational fluency, it's important to remember that computational fluency is more than getting an answer or solution. We are assessing for accurate, efficient, and flexible methods across all 4 of those operations. So not just the answer, but how they get the answer, and having multiple ways to get to a solution or answer. So there's that fluency and flexibility built into that. So assessment includes the content knowledge of addition, subtraction, multiplication, and division, as well as competencies such as mental math strategies, using multiple strategies, problem solving, communicating, explaining and justifying solutions, etc. So a student is proficient for their grade level if they are able to use grade level numbers. So there's always a number range assigned for each grade level, and the operations that are assigned to that grade level. And they're able to solve those computation questions in multiple ways and use a variety of tools and visuals, as well as being able to explain and communicate their thinking. So again, that proficiency is layered and quite complex. And we need to do, communication with our students as well as their families so that they understand what that means to be proficient when adding, subtracting, multiplying, and dividing in relation to our BC curriculum. So when we look at our proficiency scale, that we draw upon for providing descriptive feedback, as well as instructional planning, as well as assessing and evaluating. The emerging stage is really that initial understanding of concepts and competencies. Developing has some or partial understanding of concepts and competencies. Proficient is complete, and that doesn't mean complete in general. It means complete for that grade level. So sort of meeting that sort of threshold in terms of what we expect for proficiency and complete understanding of concepts and competencies for that grade level. And then extending means sophisticated or more complex and in-depth understanding of concepts and competencies, often making applications or connections to other areas of learning and math-to-math connections as well. So I'm going to share some examples across the grades. Here's a subtraction question from grade 2. This might be during a number talk or a small group instruction. So the question is 52 subtract 18. So it's within the student's number range, numbers to 100. Subtraction is included in the grade 2 curriculum. And then you see a list of competencies that I might be looking for and assessing. So is a student able to use mental math strategies, multiple strategies, use of visuals and tools such as 10 frames, base 10 blocks, 100 chart, and open number line? And then are they able to communicate their mathematical thinking in many ways? So when you're doing a number talk on the carpet, are students able to explain how they got to their solution in more than one way? And what sort of math vocabulary and language do they use? So you can see here on this photograph, we've got some different strategies. We have students using base 10 blocks and removal for subtraction. So they've made 52 and then they've subtracted 18 or removed or taken away 18. They've had to regroup some of those 10s into ones so they can remove 18. You can see students here are compensating. They're adding 2 to the 18 to make it an easier number for them to subtract in their head. Similarly down here, we've got an open number line where students are looking for the difference. So what is the difference between 18 and 52? You might think of that algebraically. 18 plus what equals 52? And that shows that deeper understanding of that relationship between addition and subtraction. And then using that open number line to add up to find the difference. Decomposing by place value, decomposing other numbers to subtract in a cumulative way. And then comparing here the difference. And again, some students might have what we call the traditional algorithm here in North America. There's lots of different algorithms for subtracting. And again, when students are sharing a traditional algorithm, I'm checking to make sure that they actually have that understanding of the numbers. You can see here the student has regrouped a 10 and added it to the 2, so it's a 12. Sometimes a student just puts a 1 up there, and I just check to make sure that they understand why they're doing that and what that means. And again, an example of proficiency for grade 3. This is an addition question with numbers, 3-digit numbers, which is the number range for grade 3. You can see a variety of strategies and tools. We've got base 10 blocks over here again, and we have an open number line as a tool or a visual to support subtraction or addition in a couple of different ways. You see decomposing by place value, so they're also showing their number understanding. And again, that compensation here, they look at 482 and they think, oh, that's pretty close to 500. What could I add to 500 to make that easier for me to add in my head? And then subtract those numbers afterwards. So again, multiple strategies here, what we would call the traditional algorithm. And then here, sort of an expanded form of that. So instead of adding 2 and 9 and putting a 1 in the ones place and adding the extra 10 in the tens column, we've added 2 and 9 and put 11 lined up by place value. And then 80 plus 50 is 130, 40, 400, and 200 is 600. So we see all those parts and then we add them up together. And then an example of proficiency from grade 5, which is multiplication to 3 digits. And again, some of those other competencies. Multiplication to 3 digits, the number range for grade 5 is up to 1 million. This doesn't necessarily, it falls within that range. And again, you're looking for students to use a range of strategies. Across the bottom here, these are all partial products, whether it's in an area model, or we're multiplying out through partial products here, or we're using the box method. This is still essentially the same strategy, just in 3 different forms. So we would want to see that students have some other strategies as well, such as the distributive property, again, decomposing, and then recomposing, halving and doubling, etc. So again, where do we start? When we're designing for learning, and then our assessment follows that, we begin with a learning goal. So we're combining curricular content and competencies. And you can see here for that multiplication example, I've taken some grade 5 math learning standards. I've combined them into a learning goal that is my focus for my unit of study on multiplication. But then I've put it also in student language, and that's what I might have posted up on the board or in some sort of chart. So I can use what I know about numbers to multiply 2 and 3-digit numbers using flexible strategies, and I can share what I did, right? So again, students can reflect and self-assess on where they are in their learning in relation to that learning goal. And then from that learning goal, I would, that describes what proficient is, and then I would describe what extending, developing, and emerging is based on some of that language from the ministry scale. So initial, partial, complete, and extending. Again, so that I can look and see what next steps are for some students, and that they can use that in their self-assessment and goal setting as well. So in a classroom, this is an example, from this grade 4-5 class that we had, and we were doing some practice questions, and I came around to a student, and this is what they had on their paper. And so what can we learn from that? Can we determine proficiency with just the information on the paper? So what do we see? What do we think the student knows? What can the student do? And what feedback might you provide to the student, or what questions might you ask to get more information to see if we can actually determine proficiency? So we have a solution, and we have some information about their strategy, but maybe not, we don't have a complete understanding. So we're going to need to talk to the student or have them explain or write it out or draw it out a little bit more. So I think we need to be mindful of that in terms of the types of evidence that we collect. And that's where we need to have those interviews and have those conversations with students to see if they really understand and can explain their thinking and strategies. Often, we've talked in this series about computational fluency that we have a variety of ways we practice that. We practice during math games or instructional routines like number talks. And then we might provide practice questions on whiteboards that are done collaboratively or written in math journals or notebooks, and maybe on apps. So how do we collect evidence of learning when students are doing all those different forms of practice? And so on the portal, we have some up now and some more will be coming, but for computational fluency for K-5, there will be these class profile charts. So again, they're grade level specific. Because the learning standards are grade level. But this first one, if you had a combined 2-3 class or 1-2 class, you write the students' names that are in that grade level. And this could just be on a clipboard. And as they're doing math games or as you're doing a number talk, you might be noting down when you're noting proficiency. And it could just be a check mark, or it could be the date. It could be the date and a P for proficient, or the date and a D for developing. And you know what you did that day. You have your day plan, so you don't need to write a lot of notes. But if there's certain strategies that students are using for the first time, you might note that. Or if they're not using certain strategies, you might note that. And then that class profile can inform maybe some mini lessons that you need to do with the whole class, or how you might support small groups that have similar either competencies that they need to develop, strategies that they need to develop, or a number range that they need to develop. So you can group children in lots of different ways, depending in terms of, what their learning goals are. And then the second document here is just for one student. So it's student specific. And again, computational fluency is something that develops over this whole school year. So you might do one of these each term for a student to track their progress. And you might choose some assessment tasks each term that you're going to use for assessment purposes, and then to evaluate when you write report cards. So again, there's a place at the bottom here. So this might be, computational fluency questions recorded in Math Notebook on, May 2nd, or it might be number talk, on, May 3rd. This one might be math games during math workshop on May 8th. And so you know what the task was, and then you can write down again the date and then whether you're determining, proficiency or not in relation to those different learning standards. You can also then see if you've got data for all those things that you need to assess and communicate student learning around. So it's just some data recording forms that we're creating to support teachers in our district with assessment and reporting. Again, more resources on the Numeracy Foundations tiles on the portal, which are being moved to the new RichNet Hub currently and by the end of the summer. But again, if you click on computational fluency at K-2 or 3-5, you'll have a PDF, and there are those computational fluency questions and assessment of computational fluency information there on those PDFs and directly linked to those resources. Again, if you go to assessment at the bottom of the page, there's also the indicators of proficiency, those computational fluency questions per each grade, and there's an assessment tool. These are K-2, 3-5, and 6-7. They have more questions than just computational fluency, but there are some that are focused on computational fluency, and they are currently being translated into French. And again, we have these new suite. This is where you find them under the assessment tile of proficiency scales. So the K-2 ones for computational fluency are up for addition and subtraction. And I will be completing the addition and subtraction ones for grades 3-5 and multiplication and division for grades 3-5 this spring of 2024. And then those will all be posted on the portal and then on the hub. This is what the addition and subtraction to 100 proficiency scale looks like for grade 2. You can see addition and subtraction is both the facts to 20 as well as addition and subtraction to 100. For grade 3, that would be to 1,000. And then it increases with numbers as students get older. And then includes decimal addition and subtraction in grade 4 and grade 5. You can see sometimes we've numbered, like uses 3 or more strategies, and then it lists the strategies to look for. Strategies also increase in complexity. So some of the more complex strategies are not included in emerging and developing. But again, 2 or more for developing, 3 or more for proficient, and then 3 or more for extending, including being able to make connections between those strategies. And then this extends to or develops further to addition and subtraction to 100 and being able to solve problems with numbers as well when we're adding and subtracting. So that's just an example of the proficiency scale. You could enlarge it onto 11 by 17 because the print is quite small, but you could use it once a term, or you could use the same one over the whole year and just highlight it with different colors for one student on one form and see how they're developing over the year. And that's a great tool to help students reflect on their progress as well. In that assessment tile, there's these computational fluency questions. Again, there's 4 questions for each grade level, except for kindergarten, where there's only 2. And these questions are meant to be used over the year to monitor progress around computational fluency. So 3 or 4 times over the year, you can use the same questions because getting an accurate solution is part of this, but it's also about showing how students have fluency and flexibility with the different ways they get that solution. And that's why there's those boxes for them to record the different ways they could solve. For example, at grade 4, if you haven't done addition and subtraction of decimal numbers yet, then it wouldn't be fair to assess that question, but you might leave it there and not cross it out just to see if students attempt it. And that might give you some insight into what they know. So those forms, again, are available on the portal. As part of the assessment tool, there's a K-2 one and the 3-5 one. This is an example of a computational fluency task connected to number concepts that's embedded in that. So it describes the text, the task, what to observe and listen for, and then what indicators of proficiency there are for grades 3, 4, and 5. And again, there's recording sheets included in that tool as well. Also on the portal are assessment and reporting supports for educators. As we come to the final summary of learning in June, suggestions for how to frame your report card comments, what potential descriptive feedback could look like, what next steps could look like. There's another one for written learning updates during the year. And then for those learning updates that don't have a formal report card that are done in person, or on a phone call, there's what is numeracy, and those two what is numeracy documents, because we're reporting and talking about numeracy as opposed to mathematics at that time. So those are all available to download as PDFs on the portal in the elementary reporting guidelines tile. So again, as we come to the end of this series on computational fluency, just invite you to think about what different types of assessment strategies that you could use to find out what students know, understand, and can do regarding computational fluency, so that we're getting an accurate portrayal of where students are in their learning. What types of feedback might you provide to help move students' learning forward? How might using that proficiency scale and that list of strategies help you say, oh, I noticed that you often decompose when you're adding and subtracting numbers. Is there another strategy you'd like to learn or practice more of? So that's like an observation in that descriptive feedback that's going to move them maybe towards using a different strategy to expand their repertoire. What different types of evidence of student learning can you collect? So again, thinking about those products, those observations, and those conversations that you might have with students. And how will your assessment approaches inform your instruction and how you provide learning updates about your students? So again, how are we going to collect data? And then we need to report on that. But then how is it also going to inform what mini lessons you do, what small group instruction you do, etc. So I hope you have found this series on computational fluency informative and made connections to the BC curriculum. And thank you for joining us.